Good morning, everyone. I am John Mann, Director of Education for Lakeside. And as you know, we are celebrating the South Week, and for this today we'll be exploring the climate. And today's lecture on hurricanes will help us understand the science behind of nature's most powerful forces. Tom retired recently following a 33-year career with the National Weather Service and finished his time with the National Weather Service as the meteorologist in charge of the office in Wilmington, Ohio, where he led a team responsible for providing forecasts and warnings for much of the southern half of Ohio. This office was also responsible for areas affected by the landfalls of Category 4 Hurricane Harvey in 2017 and Category 5 Hurricane Michael in 2018. I would also say that later today, the environmental lecture, which is typically in this space at 1:30, is being moved to the Agler Room, which is off the Fountain Inn lobby. The reason being is this building will host a talent show this evening. So I just wanted to make note of that. But I would ask if you'd please mute your cell phone ringers if you haven't already, and help me in welcoming Tom Johnstone.
Good morning. Thank you. Thanks for being here today. Thank you, John, for inviting me back for a second year. I actually came last summer and spoke about tornadoes, especially with a real tilt on tornadoes that affected the Buckeye State. So, as John mentioned, I'm a native Ohio, and I grew up in Cincinnati. Went to Ohio State University. I was one of the first graduates of Ohio State's Atmospheric Science Meteorology program in 2001. Went on to work 33 years with the National Weather Service, 8 different weather forecast offices. I also worked for the satellite branch in Washington, D.C. for several years. So quite a long, involved, and noteworthy career, just in terms of the amount of stuff that I saw and led. And John hit on some of that, and we'll do a deeper dive into some of the hurricanes that I worked. While I was at Ohio State, I wanted to get some tropical experience. And as I mentioned tropical, boy, did we have a tropical rainfall here in the last few days, right? So I was in Nashville. I live in Nashville now, but we were having some storms. And then I saw some of the rainfall rates that were showing up around Sandusky, Kelly's Island, this area, wow. Saw some flooding driving in too. There's still some areas that are underwater from that. So these rain bombs, these tropically connected, localized extreme rainfall events of 10 to 20 inches are becoming more frequent. And we'll talk a little bit more about the processes behind that. I mentioned I worked 8 different offices, so my journey with the National Weather Service was one that's aligned with our theme this morning, and that's going south. So grew up in Ohio. My first job out of college was in Maryland. Came back to Kentucky for a while. Then I went to Greenville, South Carolina in 1994. And South Carolina, especially Greenville, which has become quite an emerging community and a place to be now, it was a small southern town in 1994. So for an Ohio boy to move to Greenville, South Carolina was quite a bit of culture shock. So my career has taken me to Nashville, to Corpus Christi, Texas, to Tallahassee, Florida. And then at the end, I decided to get away from the coast. Hurricane Harvey in 2017, Hurricane Michael in 2018. I worked both those events as meteorologist in charge of the Corpus Christi and Tallahassee weather offices, respectively. I did not want to see any more tropical weather. When I was at Ohio State, I wanted to get some tropical experience. Jay Hobgood, who became the first thermodynamics professor at Ohio State University, was a tropical guru, so we were always talking about tropics. I actually applied to be a hurricane hunter at one point, to fly into hurricanes. Luckily, I didn't get that job. But I got some tropical experience, and after a few years, I realized it was enough. So I think people say that they'd rather deal with a hurricane than a tornado because you can see the hurricane coming, where the tornado develops so quickly. But what I saw with hurricanes was worse than anything I saw with tornadoes. And we'll show some examples of that and what's going on there. So one last thing that I did while at Ohio State, I've spent almost 4 years, working at the Bird Polar Research Center. While I was there, I spent my days processing ice cores, applying timeline techniques to match up chemical and oxygen isotope analysis of ice core data, some cores going down thousands of meters, to then recreate past climate. So in the late 80s and early 90s, I was working with a team that was on the forefront of understanding the changing climate and the human impact on climate that we see. So I think there's There's still some debate about how bad climate change is going to be. The data that I saw then, including melting glaciers and increased warming through industrialization and through the population time, indicated we're almost certainly modifying our climate as humans. I think there's debate how bad it is and what we should do to fix it. But the data I saw, the data that I had my hands on, the ice core samples that I processed, ran through the mass spectrometer and analyzed the data, indicating it's warming. And it's almost, the only way to explain it scientifically is that we're having some impact on it. So I will have a little bit of climate in here in terms of hurricane changes. One of the things that I think surprised people at my tornado talk last year was that everyone would think that the warming climate is going to mean worse and more bad tornadoes. It doesn't. In fact, violent tornadoes have been decreasing as the earth warms. So there's contradictions. There's things that are maybe not as linear as you would think they'd be. But what's happening is the poles are warming faster than the equatorial regions. So that changes the gradient of temperatures from south to north. It's not as strong a gradient, resulting in weaker jet stream and resulting in less violent tornadoes. And that's also affecting hurricane trends. So it isn't always just, everything's worse and badder and more frequent. It's very complex and complicated. So interesting stuff. But we're going to hear talk hurricanes today. So I'm going to tell you everything you want to know about hurricanes, how they form, why they form, what they're made of. I'm going to walk you through some scenarios in terms of you being able to understand the data and the impacts from hurricanes. Obviously, we don't get hurricanes here. Well, I'm going to talk about one hurricane that hit Ohio. It just isn't water close by. And Lake Erie, while it does get warm enough to support hurricanes, it isn't warm enough, long enough, and deep enough to support hurricanes. So we don't get hurricanes to form in Ohio. So we are entering hurricane season. Officially, hurricane season runs from June 1st through November. The strongest hurricane I ever worked was the middle of October. So you can get strong hurricanes well into the month. Try my pointer here. So we're about right here, and we're right in that period where hurricane frequency is about to tick up. One thing to notice is it's really a rapid pickup after about the 10th or 15th of August. So a lot of times you'll hear people around around August 1st, August 5th, late July, everyone's like, boy, slow start to the hurricane season this year. That's normal. So this is an 80-year, give or take, record of hurricanes. I think if you looked over a 10,000-year record of hurricanes, this would be much smoother, but the peaks would be the same. There's just some data limitations which don't allow this curve to be perfect. But you can see when hurricanes are most frequent, peaking on or about September 10th. So very warm waters here, cooler waters here. This is the area where the warmest waters and the weakest wind shear occurs in the atmosphere. That's where they're superimposed on each other. So there's about a 6-week period of really strong tropical activity in the Atlantic Basin. This is 2025. It was a below average season. Don't tell people in Jamaica. It was a below average season. Actually went to, my partner has family in Jamaica. We went down for a funeral this year, and Kingston wasn't affected that bad, but there were a lot of parts in the western part of Jamaica that were still without power, and that was 4 or 5 months after the hurricane. So Hurricane Melissa, which is this track right here, an October storm was devastating. Only one system affected the United States. That was Chantal, relatively minimal impacts. So a below average season and a much below average season in terms of impacts to the United States. And we'll talk a little bit more as the talk goes on that there's different kinds of seasons. There can be active seasons where nothing hits the United States, and there can be inactive seasons like 1992, where one storm, Andrew, changes everybody's lives, even though the rest of the season was very quiet. South Florida and parts of Louisiana were devastated by Andrew. Forgot to mention at the beginning of this presentation, a lot of the presentation that I'm giving today was provided to me by the National Weather Service in New Orleans. So I have friends that work there. This is some of the tropical presentations they give their residents. Obviously, New Orleans, southern Louisiana, fair amount of tropical activity. So you get to see what the people that live there see, with my experience baked in terms of what I saw personally at the Gulf. All right, so the outlook for this year. How bad is it going to be? That's one of the questions you get as a meteorologist in the tropical areas. How bad is this hurricane season going to be? Again, what does bad mean? Is a lot of storms bad, or is one storm hitting you bad? So the numbers don't really matter. It's just a numbers game, though. So I'll get into why this year is forecast to be below average, and I'll describe what this forecast area encompasses, because it's important to understand. So we are now looking at a 55% chance of below normal, just a 10% chance of above normal. And you can see your normal averages are 14 named, 7 hurricanes, 3 major hurricanes. We've had seasons with over 30 hurricanes and well over a dozen major hurricanes. We've had seasons with just 5 or 6. So it varies year to year, and I'll show you one of the big factors in that. So El Nino. We are in an El Nino year. The El Nino conditions are getting stronger as we speak, looking to peak sometime later in the winter season next year. El Nino does affect Ohio weather, especially in the wintertime with a little more precipitation and more severe weather, but it has a big effect on tropical activity in the Atlantic Basin. What is El Nino? Probably heard of it before. You understand generally. It's a change in oceanic heat distribution, especially over the Pacific Ocean. In an El Nino year, the waters in the equatorial Pacific, the areas off Peru, areas off of Costa Rica, Panama on the Pacific side, are warmer than normal. People that have been living there for hundreds of years notice these years, every 3 to 5 years, where the waters were warmer, the fishing patterns changed, the weather changed. Nobody really knew what it was, but it came about and became noticeable around time of Christmas. So the Christ child, El Nino, was kind of the gift that the weather was giving in these El Nino years. So when there's very warm waters in the equatorial Pacific, especially along the coast of the Americas, it changes the weather patterns over the Atlantic Ocean, resulting in more wind shear. So what we see in El Nino years is you have more hurricanes in the tropical regions of the Pacific. You have less hurricanes in the tropical regions of the Atlantic. And the reason is because all the storm energy being focused over the Pacific creates stronger winds in the upper levels of the atmosphere of the Atlantic, and that's not favorable for hurricanes to form. This is the Atlantic Basin. So when I give you numbers on a forecast for how many storms are expected, it isn't how many storms are forecast in the Gulf of Mexico, how many storms are forecast in the Caribbean Sea. It's the entire Atlantic Basin. We do get hurricanes to form in the open Atlantic. Some storms, they're called fish storms. A fish storm doesn't affect anybody but the fish. And some shipping lanes that are out there. So this is the seasonal-wide forecast from June 1 to November 30th. That's those numbers I showed you right here. I'll go back one more time. That's pretty skillful forecast. But again, all it takes is one storm in the wrong place to change millions of lives. So we'll see what happens this year. Odds are it's going to be a quieter season. Here's the names. See if you or any of your loved ones have a hurricane that might be named after them this year. We used to, in a couple years, we've run out of names. We've blown through all the names that are on there. In the old days, 10, 15 years ago, we used Greek letters to continue the list. We ended up having a couple of those have to be retired. There's the World Meteorological Organization, after a major hurricane, can make a decision to retire a hurricane. So there will never be another Hurricane Michael. There will never be another Hurricane Harvey. There will never be another Hurricane Eta or Iota for 2 reasons. We don't use those anymore, and they're retired. So now we just have a secondary list of hurricane names. So that list isn't really important this year. We probably won't get through the W storm, but if we do, there's a whole other list that we reset and start using those. All right, hurricane trends. This is a little complex. I'll try to explain all this. It's a lot of data, but a question I get asked a lot, and something I think about a lot is our changing and warming climate creating stronger, more, worse hurricanes? The answer is maybe. And I'm going to qualify it with a couple things. The top here is U.S. landfall hurricanes going back to 1860. In terms of landfalling hurricanes, the trends are pretty flat. And this is including, and I'll talk more about this 1860 to 1930 period because it's important when you look at the data. But if you look at major hurricanes, there is an upward trend over time. We have seen more major hurricanes. The problem is that the 1860 to 1930 period, and really up to the 1950s, Before weather satellites, lots of storms existed without ever being sampled or tracked. So maybe if it didn't hit the coastline and it didn't hit a ship, we may never even know that a hurricane existed. So there's an underreporting bias from the 50s all the way back to the 1860s. When you normalize everything out and look at hurricanes and major hurricanes, it's a flatter trend, but still a little up on the major hurricane. So going back to 1860, there's strong evidence that we've seen a slight uptick in major hurricane frequency, but not more hurricanes in general. Major hurricanes are the bad ones, though, so that's important. We're seeing hurricanes that are moving a little slower because, again, the overall wind pattern in the atmosphere is lessening as the climate slowly warms. So storms are moving slower. The oceanic heat content is greater. We're getting higher rainfall amounts, and that's expected to continue moving forward. So this is just it's not going to happen overnight. It's going to be worse every 10, 20, 30 years. But the overall scientific data does support not more hurricanes, maybe more major hurricanes, certainly more heavy rain, and more hurricanes that rapidly intensify. We're seeing that trend as well. If you look at just energy, this is a hypothetical number which just looking at all the conditions in the atmosphere, including the amount of heat in the oceans. And hurricanes, I'll show you in a minute, hurricanes don't just need warm water, they need warm water that extends down 50 to 100 feet. So that energy has been increasing back to 1950 when we've tracked this. There's a dip, but the overall trend is that it's slowly increasing. So this supports why we're getting a few more major hurricanes and something we're having to deal with. Any questions about any of the data that I showed there before we go on to dig a little deeper into hurricanes? Awesome, thanks. If you have a question, just raise your hand and we'll get right to it. Okay, so how many here have heard of the hurricane cone, the tropical weather cone? This is one of the most poorly understood products the National Hurricane Center produces. This is not a cone which tracks the scope of the hurricane impacts. The cone traditionally, well, the main point of this slide is that the default cone graphic on the nhc.noaa.gov website is going to not just show the cone with the forecast center point, it's also going to show any watches and warnings to better convey that the impacts of the hurricane extend well beyond the cone. The cone is simply a representation of where the hurricane is expected to track the center of the hurricane 66% of the time, which means 33% of the time it's going to track outside the cone. So the official forecast is right in the center of the cone, but 33% of the time the hurricane's going to track outside of that cone. So it is not don't look at this as a perfect representation of where the hurricane's going. There's air that is implicit in every weather forecast. There's air that's implicit in the hurricane forecast as well. So you can see what we actually see when you break down and look closer at the cone. What we're actually doing is we're taking each of those 24-hour or 12-hour forecast points and we're drawing a circle. And that circle represents the average air at that forecast interval. The circle gets larger as you go out in time because why? There's more air with more time in a forecast. So our weather forecasts nationally now are as good at 5 days as they were 2 days 25 years ago. So with time, our forecasts are getting better. We're seeing that with hurricane forecasts. But still, the further you go out, that butterfly effect, that unpredictability effect takes over. And it gets harder for us to accurately predict exactly where it's going to be. So we have air, and the air is represented by these circles. You take all the circles and you spread them out in time, and that is what you use to develop your cone. They're going to try something new this year. We're going to have an experimental second cone. And the second cone that's going to be available for 2026 for the first time is going to show your traditional 66% cone with a 90% cone to give a more reasonable worst case scenario. It's very unusual for a storm to track outside of the 90% cone. So in this case, you can see what we have, and you can see how those two things are produced. So it's a larger cone, but it's going to be segmented to show the 66 and the 90%. This is important when you're trying to make decisions on if your property or your loved one's property, your family's property in Florida, Louisiana, might be affected by a hurricane. So these are the tools that folks that live in tropical areas look at. So the official track, the National Hurricane Center meteorologists are the best in the world. The forecasts they produce continue to beat any computer model guidance with one possible exception. I'll talk about that in a minute. Any numerical guidance year in, year out. Trust what the Hurricane Center folks say. You can look at all the models you want and watch all the social media people that are going to pop up with all these scary scenarios. I've learned, people that know learn, take what the Hurricane Center puts out as the official forecast as your best guess. So there's 100-mile air 5 days out, so that's a lot, right? I mean, the Hurricane Michael, one of the most powerful hurricane I ever worked, I mean, really the core of that storm was only 100 miles wide. So if you have an air of 100 miles 5 days out, just because that storm's missing you 100 miles to the east doesn't mean you aren't in danger. So remember, air is part of the forecast process, and don't take what's put in as gospel. All right, here's the official air over time. You can see basically the trend here is that the air is getting shorter and lower as we get closer to today. And that's just every year. There's improvements that are made in modeling, the human understanding of the storms, and everything else. We learn every year, and the result has been better and better forecasts of both the track and, for a long time, intensity lagged. We've gotten really good in the last 10 years at predicting rapid intensification and overall intensity changes in hurricanes. 10 years ago, I would give a talk and say, we really don't have any skill at all forecasting whether a hurricane is going to strengthen rapidly or weaken rapidly. Not perfect now, but it's a lot better than it was. So that's a good thing. And here's your intensity airs. And again, you can see the black line is your official forecast. All the guidance in the world, these are all just different computer model tracks that all the hurricane forecasters use. The best continues to be the National Hurricane Center meteorologists that use all this other data to make the best forecast possible. And here's the official forecast. Here's different model forecasts that are showing air, low air, inconsistent, consistent, but down here, low air and consistent, that is the Hurricane Center. They make their money by being consistent and better than all the other computer model guidance. So trust what they have to say. All right, AI came of age in 2025 for hurricane forecasting. If any of you were at my tornado talk last year, you might remember that I talked about some of the AI tools that have developed for forecasting tornadoes and severe weather. We are at a huge change in terms of meteorological predictions using data, statistics-based modeling versus dynamic-based modeling. When I went to college, I had to learn how to understand and solve the equations for meteorology. So the way that meteorology and forecasting has always worked is we run computer models that simulate the atmosphere using some equations. In the early days, there's a movie out now that talks about the D-Day weather forecasts. Yes. And they had some very weak computer abilities, but a lot of that was just simply meteorologists trying to solve and trying to use their understanding to make a weather forecast. With the advent of computing and stronger and faster computing, we were able to make much better forecasts with time using computers. But it still requires a lot of computational intensity. It's a lot of solving. There's a lot of assumptions and a lot of gaps and a lot of error. What AI models do is they look at through some pretty complex statistical techniques and different learning procedures. They just look at data relationships. So when I learned that some of the deep learning models that were investigating doing weather predictions were not only producing accurate weather forecasts, they were able to demonstrate that the relationship between all the different data that they were showing was those equations. So AI learned the equations of meteorology just looking at the data and how the weather was moving along in patterns. That blew my mind. That was kind of like, we can't ignore this. And I think that the meteorological community is still divided between your purist, your traditional, it's not science if you aren't solving equations and understanding all the dynamics, the thermodynamics and all of that happening. That's not meteorology. And this new breed of AI, deep learning experts that are simply looking at data, putting in good data, and from that data, the model is learning how to forecast weather just through those data relationships. It's more complex than that, but that's a pretty good idea how it works. And it's shown huge positive benefits. So I talked about severe weather last year with hurricanes. This was one of the first storms I noticed. This was Gabrielle last year. The track The yellow is it's the Google's DeepMind is the prediction engine that runs this. It was pretty accurate for Gabrielle. Well, I went back and looked at the entire season. So 2026, we're going to incorporate this more. 2025 was the first time the Hurricane Center looked at any artificial intelligence. The main thing to notice is your green line, that's your artificial intelligence. That's the machine learning, that's the Google DeepMind. And this right here is skill. The black is the official forecast. So I mentioned before, the Hurricane Center is always the best, better than any model. It was different in 2025. Google's DeepMind was better than the Hurricane Center. That blew my mind quite a bit to see that kind of relationship. So you can see all the different other forecasts that's available there. When you look at air, again, the most important line is your green line on the bottom. The lowest air forecast for the whole season last year was Google's DeepMind. So artificial intelligence beat all the other computer guidance we had. Last but not least, here's intensity. The darkest green line on the bottom is your Google. And then your official tracks and other tracks are above that. Just one season. I'm not going to make sweeping judgments just based on one season. But everybody's looking at artificial intelligence in hurricane forecasting now. So including the Hurricane Center forecasters. So I think last year they kind of used it just in parallel and said, let's see how it does. After the season was over, they went back and looked and they said, this is not something we can ignore. And that's something that happened with severe weather forecasters too. After a couple years of using these tools, they realized this is pretty good. It runs fast, it learns well, it's pretty good. We still need a human to make it all come together and have people understand what the impacts mean. But it's a changing world, and it's changing weekly and monthly in meteorology in terms of the ability to forecast impacts from weather. Pretty cool. All right, any questions about any of that before I go into a little more of a deeper understanding, provide with you a deeper understanding of hurricanes and everything else? Awesome. All right, real quick. So on the Hurricane Center's webpage, it's starting about August 1st, I'm there every morning. Go to the National Hurricane Center website. On their front page, you're going to see tropical weather outlooks. You're going to see a graphic which shows any areas of potential development. If there's tropical storms or hurricanes, those are going to show up on their front page. You can click on them, get all the information about what the storm's strength is, its history, where it's likely to go, and its impacts. So pretty cool resource. So the tropical weather outlook, and you'll hear about professionals will call these lemons, cherries, and oranges. And those are just potential for development areas. They're not tracks, they're not impact areas, they're just areas of higher or lower likelihood, and then existing storms. And they're also going to have areas that people are watching because there's something showing up on satellite, but are not expected to develop. So this is a great one-stop shop. This graphic, which is available right on the front of the hurricane website, is a great place for you just to know what's happening in the tropics and have a little bit of a heads up what's going to happen the next few days. So the tropical weather outlook, again, I mentioned that before. It is not anything about impacts. It's not a track. It's just areas where things could develop. So once there's a hurricane, here's one that's tracking right towards Tampa Bay. The S, anybody want to guess what the S stands for on here? Tropical storm. So that's the location of a tropical storm. H, anybody want to guess what H stands for? Hurricane. M, what does M stand for? Major hurricane. So this is a nice little, this is the cone for this Milton storm back in 2024, where it's supposed to be a tropical storm, strengthened to a hurricane by 7 a.m. Monday. By 7 p.m. Tuesday, a major hurricane, and then a major hurricane at landfall sometime around 7 p.m. Wednesday. Again, there's air. So 7 p.m. Wednesday could actually be 7 a.m. Thursday or 7 a.m. Wednesday if the storm changes. Remember, there's a circle, and that circle encompasses not just left or right airs, but forward or not as forward airs. So this is just an official forecast, and your mind needs to say, okay, that's the official, but within that official forecast, there's air. So just keep that in mind whenever you're looking at a hurricane forecast. The spaghetti models, you've probably heard of spaghetti models, or you might have seen a website showing spaghetti models. Just a lot of different ways. Some of these are simply a representation of where that hurricane would go if it kept moving in a straight line and didn't move at all. Some are much more complex than that. And some are going to be your official forecast. So they're a nice tool for you to visualize some of the spread that's going on, but you wouldn't want to look at this and say, oh yeah, I don't like the way that model's looking, because it might not be rooted in anything realistic at all. That's where the Hurricane Center official forecast is best. How about storm surge? One of the most deadly threats from hurricanes. I'm going to talk a little bit now about what storm surge is, how it forms, how we predict it, and some of the things that are kind of the nuance associated with the storm surge. Storm surge watches and warnings are issued 48 to 24 hours in advance. I'll talk about how these storm surge forecasts are developed in a second. But what storm surge is water depth over normally dry land. So a wave running up on the beach is not storm surge. So it's more like a bathtub filling up. In fact, when you measure storm surge, you've got to find a place where you don't have any evidence of wave action. So after Hurricane Michael, the USGS went in and they marked a spot 21 feet above the mean high water, the normally dry part of the coastline there in Florida. The problem was that was wave action. That was not actually the water level. So what matters with us, with hurricanes and storm surge, is how much higher is the ocean level than it normally would be. And then the wave action on top of that is extra. So you've got to find a place that was relatively protected to make that measurement. So the USGS tweeted something out that wasn't official and wasn't accurate in terms of how deep the storm surge was. So storm surge is, imagine just the water level rising 12 feet from where it normally is, and then waves on top of that. So at Mexico Beach, they had, in the end, about a 15-foot above normal storm surge with 25 to 30-foot waves on top of that. So and it's the wave action. The water's bad. It's the wave action that does all the destruction. So there's plenty. I'm a digital meteorologist now, so I'm a retired National Weather Service meteorologist, but my work is doing digital meteorology. I do weather broadcasting on the internet for a group in Nashville called Nash Severe Weather. We've got over 500,000 followers across platforms. We have 40 to 50,000 people watching us. More people watch us than watch the TV stations in Nashville now during severe weather. But not all social meteorologists are trustworthy. So if you see someone that has a map of the US and has a big X over Florida and then skull and crossbones and a big nuclear explosion, death coming to Florida, probably don't want to trust that person. The Hurricane Center, your National Weather Service, your media, and the growing digital meteorology contingent out there is going to provide more trustworthy data. You probably all use an app on your phone. My mom will say, Tommy, the app said it was going to storm all day today and it didn't rain. I'm like, that app is just data being pulled from somewhere. You have no idea where. The Weather Service doesn't have an app. We could probably have another talk on that another day about why that is, but it should. Just be aware that your weather apps are not going to give you any information that's had value added to it. It's usually just going to be raw data from some computer model or another. Not a bad place to start, but if you really need to know, look at your official sources, especially weather.gov. Looking at it is different than reacting to it. And this is an important point, right? I enjoy some of the craziness that some of the social meteorologists do, especially when there's pictures and other things going on. I try not to react. I take it for what it is. Not always trustworthy, sometimes entertaining. So here's some computer models. Again, these are all fantasy storms that never happened, and we won't talk about that other than these were computer model forecasts. And you'll see these on social media. People love to share a computer model 15 days out and say, looks bad for New York City. It's never going to happen. It's just a simulation that ran awry. Trust the Hurricane Center. Trust your official products. All right, some basics. Now we're going to tell you a little bit more about what hurricanes, tropical storms are, how they form, how they're structured, and some of their impacts. Get a deeper look into those kind of things. I mentioned before that Lake Erie, especially the western basin of Lake Erie, probably could briefly support some kind of tropical development. I've seen tropical systems form over waterlogged land of Texas and Oklahoma, where storms develop the characteristics of a tropical storm over land. It can happen, it's just very, very rare. So and typically here we have too much wind shear as well. So never say never, but it's just the size of the lake and the amount of wind shear in this part of the world is just too great for tropical systems to form. 80 degrees is a rough cutoff. We know that, you go out on Kelly's Island, you can see that the climate used to be much different here, that there's massive amounts of ice and glacial scouring that happened. So when the Earth was much colder, 6 to 8 degrees colder than it is today, hurricanes still formed. We know that. They didn't need 80-degree water. The water in the Atlantic was not 80 degrees. It's all relative. So during the Ice Age, 72 or 74-degree water might have been enough for hurricanes to form because the rest of the atmosphere was cooler. And hurricanes are convection. That's all they are. They are thunder. It's a big thunderstorm that gets organized, gets big, and gets nasty. So location at least 5 degrees latitude from the equator. Hurricanes cannot form and will not cross the equator. Do we know why? You're close. You're on the right track. It's due to what we call the Coriolis effect. So the Earth, 99.9% of people would agree the Earth is almost a sphere. It's round, right? There's still some flat earthers out there, but I think we would agree the Earth is curved. It's less curved at the equator. So within about 5 degrees of the equator, the curvature of the Earth and the rotation of the Earth is not enough to put that spin on the air that storms need to form. What happens is the curvature and the rotation of the Earth causes air that's being drawn into low pressure to deflect off to the right. So instead of flowing directly to the low pressure, it curves around and it swirls in. And you see that with like the shape of a galaxy too. So that swirling motion with low pressure in the middle is due to the curvature and the spinning of the Earth. That doesn't happen at the equator. It's not enough curvature. So really, even Aruba, which is 8 or 9 degrees north latitude, is barely far enough south to get hurricanes. They really happen in the higher latitudes, require 80-degree water, require some pre-existing cluster of thunderstorms. The hurricane is a giant thunderstorm machine. So unlike a thunderstorm that pops up or the thunderstorms we just had over the lake that continue to redevelop over the same area, the hurricane is almost its own entity. Very low pressure in the middle, tons of heat being released from all that convection. So when storms are happening and rain is falling, heat is being released in the atmosphere, and that heat is what energizes the hurricane. The energy for that heat comes from the warm ocean waters. So hurricanes need to be over warm water because if they don't have that, they lose that inflow of new energy to keep that engine running. So that's what's really going on with a hurricane. If you have wind shear and the winds aloft are blowing very strong, they blow the hurricane apart. So you need to have very calm winds aloft to allow that process at the ground to keep going. And an air mass that's favorable for additional thunderstorm development. It's got to be moist. If dry air or a cold front hits a hurricane, it's going to weaken it. So hurricanes, when you have a thunderstorm in the summer, it rains, or ahead of the rain, you feel a gush of cold air, right? You feel that thunderstorm outflow. You smell the ozone in the air. It's like, oh, it's going to rain. I can smell it. I feel the air getting cooler. That cool air is a result of drier and cooler air aloft, and that cool, dry air is going to kill a hurricane. So hurricanes don't produce that cool outflow. They just are warm. So the hurricane exists to transport oceanic heat content poleward. So hurricanes are a critical part of Earth's balance. They just come with a price. So it would be a much worse climate if we didn't have hurricanes because they stabilize, they transfer energy from very hot areas to cooler areas and moisture. 39 miles an hour is the break point at which something gets a name. One of my meteorologist friends always said, you're not in the game if it doesn't have a name. So once you get over 39 miles an hour, you have a tropical depression, and 39 to 73 is a tropical storm. At that point, you get a name. 74 miles an hour or higher is a hurricane. 111 miles an hour or greater is a major hurricane. So those are your Cat 3 or stronger. What is not on here as it relates to hurricanes and their intensity? Storm surge on here? Rainfall on here? No. And those are the deadliest factors associated with hurricanes. So the original scale, and we'll talk more about this in a second, is a wind scale, but it's the other impacts from hurricanes that really kill people. So there's been an underground movement and a growing movement to change the rating system of hurricanes away from a wind rating to a more comprehensive multi-hazard rating. The problem is this is how we've always done it, and we just don't like to make those kind of significant changes. And so that's where we are right now. All right, I'm gonna have to start this video. All right, this is a hurricane about to make landfall in Louisiana. Can you identify the eye of the hurricane? Eye is pretty easy. How about the eye wall? The wall of very intense, let me go back to the start of the video again. I'm gonna start it one more time and we'll go through this. All right, let me know when you can see an eye wall. You can start to see the eye wall start to take place right there. Very bright echoes around the center is the eye wall. That's where the strongest winds occur. Here we have a secondary eye wall forms, very typical for hurricane progression, and they have outer rain bands. This is where most tornadoes would occur, is in this part of the hurricane. So those are the critical aspects of the hurricane. So we'll slow it down a little bit so you can look at the hurricane again. There's the eye. Do you see the eye wall? That's where the most intense winds are going to be in a hurricane. Secondary eye wall. Anytime a hurricane has two eye walls, it's probably weakening. So hurricanes go through a cycle by which the eye wall replaces itself, and when that happens, the storm weakens. And sometimes it never gets back to its original strength. It's kind of a process they go through that makes the storm larger, but makes the core less intense. It's called an eye wall replacement cycle. You can see all your outer rain bands right here. And has this hurricane made landfall? Can anybody tell me when landfall actually occurs? Who thinks that landfall occurs when the part of the eye hits the land? A lot of people do. It's when the center of the eye reaches land that landfall has occurred. So landfall is a kind of tricky thing to call, and you'll see experienced meteorologists say Hurricane Bertha has made landfall on the Florida coast, but it hasn't, just because technically it's not a landfall until the center of the eye is over land. So that's how hurricanes look from radar and from the outside. Those are the key things to know. The eye wall, any secondary eye walls, the rain bands, and then that landfall occurs when the center of the eye crosses land. Lighter rain. So this is a radar. So radar is going to depict the brighter the colors on radar, the more energy the radar beam is reflecting back. So yellows, reds, oranges are more intense precipitation. Greens and lighter yellows are less intense precipitation. But in a hurricane, even yellow is one of the heaviest rains you're ever going to experience. Hurricane Harvey was the first hurricane I worked and lived through, and I was amazed how fast the rain piled up in that hurricane. Really, really impressive rainfall amounts. All right, from a cartoon view, a conceptual view, here's your rain bands circulating in your eye. So once the hurricane pressure gets low enough and the storm is spinning fast enough, just due to centrifugal force, the rain and all the mass of the storm starts to get pressed outward, and a descending core of air forms in the middle to replace all that. That's the eye. So the eye is absent precipitation typically, especially in strong hurricanes. The rain bands swirl around. You've got counterclockwise spinning air at the ground. You have counterclockwise air spinning at 30 to 50,000 feet up. It's just a big machine. The engine spins, takes heat, momentum, and moisture up, and then exhausts it into the upper levels of the atmosphere at 30 to 50,000 feet up. So this is kind of a side view of what the hurricane looks like. A couple last little thoughts on the cone. So when you see a hurricane cone, take a note of its shape. So these are two pretty much similar time periods in terms of forecast time, but look how much skinnier and longer this cone is from that. What's going on there? One is a fast-moving system that's going to go that far, and so the cone's smaller. This is a very slow-moving. Look at all those D's close together right there indicate 3 or 4 days of almost no movement with a storm. So yeah, that happens. And that happened with Hurricane Harvey. All right, hurricane hazards, the wind threat. Some of the typical wind damage you get along coastal areas. You can see these homes were properly built up to deal with the surge threat, but at 120, 130 miles an hour, you're going to get destroyed by the wind. So coastlines, especially the tropical coastline of the U.S., is a tough place to build and live. Beautiful area, but it's a tough place to build and rebuild. So here are your categories in the Saffir-Simpson scale. Again, remember, there's no surge, there's no rainfall baked into the Saffir-Simpson scale. Saffir and Simpson came up with a scale to try to capture hurricane intensity just based on its winds. Category 1, very dangerous winds produce some damage. You can see your wind ranges. Major hurricanes start at 111 miles an hour. 130 to 156 mile an hour is category 4. And then category 5, of which we've had 4 landfall, is category 5 in the United States. Andrew was the one I remember from my college days, my younger years in South Florida. It also devastated my partner. My partner's from Miami. She lived in South Miami, and her home was destroyed by Hurricane Andrew. And so it was a kind of a personal storm to me. And then in 2018, I worked Hurricane Michael as the meteorologist in charge. And I never thought we'd see another hurricane that was category 5. But Hurricane Michael had 160 mile an hour winds at landfall. Hurricane Michael strengthened all the way up to the beach. It was strengthening all the way. If it had had 10 more hours over water, it would have been 10 miles an hour stronger. Unbelievable damage. So this is the rating system for the Saffir-Simpson scale. The Weather Service director, Ken Graham, former Hurricane Center director, he called these justas. Because people say, oh, it's just the Cat 1. Well, just the Cat 1 is the strongest thunderstorm you've ever been through. It's a derecho, it's a flash flood, it's a surge event, it's a major impact. So people tend to dismiss these weak hurricanes and tropical storms, and they end up with surprising levels of impacts. So this is the Saffir-Simpson scale. And again, not a surge scale. It doesn't tell you holistically how bad the hurricane's going to be. Some storms come through with a lot of wind, not a lot of surge. Some storms come through with a lot of surge and not a lot of wind. So every storm's different. Yep, Katrina was Cat 5. So they actually reclassified Hurricane Katrina. It was not Cat 5 at landfall. What happened with Hurricane Katrina was it crossed through Florida and then it weakened. And as it weakened, it got larger. So as Katrina came towards the coast, it had a large wind field, not a Cat 5 wind field, but a large wind field, and it was moving slow. And those are things that really lead to surge, which is why we had record surge from Katrina. So again, and I'll show you a little bit more about surge in a minute. It impacted the Louisiana and Mississippi coastline at such an angle to maximize the amount of surge that can possibly happen. It was a perfect storm in terms of storm surge. So how strong do you think most major hurricanes have been 3 days before landfall? Do you think when a major hurricane hits landfall in the United States, it's been strong for a while, right? No. The 10 strongest hurricanes, including Michael and Harvey as well, were just tropical storms 3 days before impact. So for a storm to go from tropical storm to a major hurricane, the 10 strongest, you can see there all the Cat 3s and everything else. That tells you that there's something in common that's happening here, and it's rapid intensification. And that is something that we're seeing more frequently. Certainly during my time of 40 years paying attention to tropical meteorology, we're seeing rapid intensification happen at a higher rate. And it's amazing how fast hurricanes can strengthen when they're undergoing this rapid intensification process. Overnight, they can go from a weak storm to a monster, literally overnight. So that's the lesson there. And here's another example. This is Michael. This was the storm of my career in terms of what I worked and what I saw. And what I saw in person at Mexico Beach, walking the beaches and talking to the people that survived. It was the worst. But it was just a 30-knot tropical depression. Within 3 days, 140 knot, almost 170 mile an hour Category 5 hurricane. It strengthened so rapidly, it just missed Cuba. It went through incredibly warm waters. And a lot of times when storms get to the northern part of the Gulf of Mexico, they churn up cooler water and the storm weakens, especially as you get into October. What had happened with October of 2018, there hadn't been a single cold front that had penetrated to the Gulf of Mexico yet. So the Gulf was incredibly warm. The waters were 84, 85 degrees, and soundings taken in the northern part of the Gulf, south of Panama City, indicate not only was the water 84, 85 degrees, it was 85 degrees 100 to 120 feet down. So it was warm water and the water was deep. There was no cool water to upwell. So Michael just churned right through all that and devastated the Florida Panhandle and devastated Georgia for that matter. So yeah, that's the story of Michael. So we're getting better. We've gotten better with time at anticipating, predicting, and modeling these rapid intensification, but we still have some issues determining exactly when it's going to happen and how long it's going to last. Is it going to be a 12-hour, 18-hour, 6-hour rapid intensification? We don't always know that, and they all are going to have significant impacts on the intensity. So when we tell people, like if your family, if your loved one, someone you care about is being told they're going to have a Category 3 hurricane, what they really need to plan for is a Category 4, because the intensity changes are still somewhat unpredictable. So this is what folks that live in tropical world are told every year. And we were telling people when Hurricane Michael was forecast to be a Category 3, prepare for a Category 4. And we caught flack for that at the time. Like, it's only a Cat 3, why are you telling people to prepare for a Category 4? Because it's rapidly intensifying and we don't know exactly how far it's going to go. In the end, it went to Category 5. So Tropical Storm Hurricane Watch, so we're expecting those conditions within about 48 hours. So it's just like a severe thunderstorm watch. So a severe thunderstorm watch is going to try to be issued about 6 hours ahead of the storms getting here. The warning maybe 30 or 45 minutes. For hurricanes, we try to get 48, sometimes 72 hours of watch time. And then the warnings are going to be about 36 hours. So that's how the watches and warnings are issued. Extreme winds in the Iowa, we have a special product, the extreme wind warning. So 2016 was the first issuance of this extreme wind warning product. It's basically it's a tornado warning, but for a hurricane. Typically, it's where we're expecting winds in excess of 115 to 130 miles an hour in the eye wall. Hurricane Harvey was the first time I ever issued those. We actually issued 2 extreme wind warnings because the hurricane was so strong and strengthening so quickly, the extreme winds extended 20 to 30 miles inland, which is very unusual. So I've actually been part of 5 extreme wind warning issuances, which I think that's a record for anybody working in the Weather Service. Not a good record to have, just something where I just happen to be in the wrong place at the right time. Here's the extreme wind warning. It's your final warning, although what we found out, people in Rockport, at least 1,000 people evacuated Rockport, Texas, when the extreme wind warning was issued for Rockport. And the reason was we issued it 90 minutes before it got there. So winds were 40 to 50 miles an hour. Everyone's phone goes off saying extreme wind warning. There's plenty of ways to get out of Rockport and get inland. And so that was people that said, okay, we're going. We didn't expect it to be an evacuation tool. It's more of a get to your place of refuge. Let's get to your safe room, get to your shelter, get someplace where you can hole up and ride the storm out. Some people actually evacuated with that. So that was an interesting story. So this is going to set off your phone. If you're in Florida, if you're in Texas, you're in Louisiana, and extreme wind warning is issued, I still have a screenshot of my first extreme wind warning going on my cell phone. Just like a tornado warning is going to set your cell phone off, an extreme wind warning will set your phone off as well. All right, storm surge. Storm surge is deadly. It's also very complex. And it's complex in that it's not just a factor of how big the storm is, how strong the winds are, and how it's moving. All those things are really critical. A small change in the angle of attack of a storm making landfall, a small change in where it actually hits the shore makes a huge difference. So there was a storm 4 or 5 years ago, the name's escaping me, near Lake Charles, Louisiana. And Lake Charles is a very flood-prone part of the state. And initially the storm was expected to go just to the west of Lake Charles and the lake of Lake Charles and all the water with a 20-foot storm surge forecast for Lake Charles. The storm shifted 15 miles to the east and went just to the east of the lake instead of just to the west. Instead of a storm surge, they had a blowout. So the water levels dropped so low that boats were sitting on the base of the water. That's a critical difference that everyone's thinking, how could you miss this? But that's a 15-mile change in forecast in a hurricane. So storm surge is very difficult to predict. So all of these things are critical. Overall, I think the most important thing is going to be the size of the wind field. So a big hurricane with Cat 2 winds is typically going to produce more storm surge than a Cat 4 hurricane with a small wind field. Bigger, weaker hurricanes are going to have more of an impact. They're just bigger. They're affecting more of the water beneath them. So the lower pressure of the hurricane causes water to rise, and just the mass and the wind of the hurricane pushes water out ahead of it. So it just basically is a storm tide that's caused by the enormity of the hurricane itself. Here's two examples. Charlie was a Florida storm, I believe 2004. 2004 was a really bad season for hurricanes, especially in Florida, where 3 hurricanes crossed the same point in Central Florida during that season. So you can see 150-mile-an-hour winds with Charlie, but a small storm. Here's an average storm, and here's Katrina with max winds of 140 miles an hour, more than double the hurricane radius, with a max surge over 25 feet at Waveland, Mississippi. And this, I was in Mississippi not too long after Katrina, and it did unbelievable damage, including some of the casino boats being pushed blocks and blocks in the inland, still laying there on the ground. I'd never seen anything like that. No, then I saw Mexico Beach. So the angle of approach matters. So these are just different forecasts of surge based on different angles coming in. So a storm coming in from one direction and a storm coming in from a different direction are going to produce different surge areas. That's pretty complex. And so a slower moving storm is going to produce more surge than a faster moving storm. And the reason for that is because the wind has more time to push the water. It isn't just the mass of the storm pushing in, it's the wind having the time. So a storm moving 5 is going to produce more surge, all things being equal, than a storm moving 15 miles an hour. And here's an example showing the different surge patterns with slightly different tracks. Very critical for people that live in the low country of Louisiana. And the reality is, 3 days out, we don't know if it's going to take this track or that track. So those tiny changes in track, the main takeaway from this whole surge thing, the whole surge discussion is so you'll all understand how complex and difficult it is to nail down exactly where the worst storms surge. Sometimes we really don't know until 12 to 18 hours out. And that Lake Charles situation I told you was more like 6 hours out. Even 6 hours before landfall, that was where the surge forecast was over 20 feet. 6 hours later, not only did they not get a surge, water left that lake and that bay and left water levels lower than normal. It's very complex. And then inundation maps will show areas that will flood. So this is something, luckily, we don't have to worry about too much here. So storm surge, this is the same as the hurricane and tropical storm watch. The storm surge watch means conditions are favorable, 48 hours, storm surge warning, and this storm surge is about 3 feet. So 3 feet is the threshold at which normally dry areas being flooded becomes dangerous. So it doesn't seem like a lot, but especially on some of the coast of Florida, 3 feet is going to get places that are normally dry wet. So 3 feet is the break point there. Inland flooding, we certainly saw this here, was not a tropical system that created the massive rain bomb that fell earlier this week and last weekend, but it was a tropical air mass. It was a tropical air mass that had kind of worked its way in. There were some really complex winds blowing over the lake and kind of converging over the islands and along the shoreline of the Western Basin. But with the amount of moisture that was in the atmosphere, a rain system set up that just continued on and on and on, 1 to 2 inches an hour, on and on and on. It can happen. Houston, probably the worst place we could have imagined to build a city, which is growing at 1 million people every 10 years, gets this as much as anybody. So I'll show some of the incredible rainfall amounts that have occurred in hurricanes in a second, but they don't always know exactly where it's going to be, and we can get flash flooding from hurricane remnants here in Ohio. We certainly have had it in Tennessee with massive rain bombs with remnant hurricane systems coming through, but more often it's closer to the coast. So the faster a storm's moving, the less likelihood it's going to produce excessive rain. Michael produced almost no flash flooding, produced horrible storm surge, but because the storm was moving at 25 miles an hour, it was in and out in 4 to 6 hours. So there was heavy rain, but it came and went. Hurricane Harvey sat over Houston for days and days and just rained and rained. So vertical wind shear, that keeps storms from moving if there's no wind shear, and it keeps the storms from being torn apart. So they just rain and rain and rain. Here's the records for rainfall associated with hurricanes. I was on a call. I was working at Corpus Christi in 2017. I actually was back in Tennessee for the eclipse of 2017. So I was in Nashville. There was totality. It was an amazing thing to see. And I get done with the eclipse, and I get back to our friends that we're staying with, and I look at my phone. I have a text message. It says, "Tom, probably need to come back." I was on vacation. Said, "Harvey's looking a little threatening." At this point, it was just a little swirl of clouds out in the Caribbean. But I said, "Okay," and I headed back. And 2 days later, after I get back to the office, we're on a call with the Weather Prediction Center, and they're talking about the rainfall forecast for Harvey. And I'll never forget, it was one of those moments where they talked about putting a 50-inch rainfall forecast for parts of Houston. 50, not 15, 50 inches. And it was funny because a later briefing, one of the emergency managers in the Houston area said, "Well, how long is that going to fall over?" And they go, "About 5 days." And he's like, "Oh, that's just 10 inches a day. We can take that." No, you can't. No, you can't. In the end, 64.5 inches of rain was the top. That's about a 5-day amount. But it was incredible flooding that occurred around the Houston area. A couple of the other ones that have occurred, you can see some of the rainfall amounts there with Amelia, Easy, Claudette. All these were associated with massive flash flooding and river flooding. But Harvey takes the cake. Harvey was something special. So the rain bands are critical. Never going to get the localized extremes. So you're going to see a rainfall forecast, which is going to show a big blob. But within that blob, there's going to be localized higher amounts for sure. And so here's what a rainfall forecast from the Weather Prediction Center is going to look like. In this case, this is 10 to 20 inches of rainfall. People in Ohio say we never get that kind of rain, but we just got 10 to 20 inches of rain here this week, so it can happen here. But this is what a forecast of rainfall. But this is a deterministic forecast. It could be wrong. We try to have some kind of guardrails of probabilities where it could be higher or lower, but this is the best guess forecast. And the heavy excessive rainfall outlook that the Weather Prediction Center puts out will also highlight areas of high risk of, just like convective outlooks, like high risk severe weather, high risk of flooding, moderate risk, marginal. So we can pinpoint areas that are most at risk for inland flooding from hurricanes and tropical cyclones, and you can look at those data too. So we've all probably heard the 100-year event, right? 100-year flood, 1,000-year flood. Do you understand what that means? Do you understand what a 100-year flood means? Because some people think that if you're hit by a 100-year flood, you're good for another 100 years. And you're not. It's a 1% occurrence interval. So a 100-year flood is going to happen, on average, once every 100 years. But those 100 years could be back-to-back years. It could happen 3 times in 5 years, and then not again for 1,000 years. So it's just a percentage. A better way to think of a 100-year event is a 30-year event, because most mortgages are 30 years. So a 100-year event is going to have a 30% chance of occurring during the time that your mortgage is being paid. So if you live in a 100-year floodplain and you have a 30-year mortgage, now you have a little more of a reasonable time frame to think, okay, I could be impacted by something. It could happen next year, or 30 years, or 50 years, but I'm at risk. So the higher the number, the lower the annual risk. But what this doesn't capture, and this is something that the weather and the preparedness community is talking about more and more, is this is based on the past. So we already talked about how hurricanes are most likely becoming, on the higher end, are becoming more frequent major hurricanes. They're producing more rain due to slower motions. And we're getting rain bombs at a higher frequency as well, because the atmospheric moisture content is just higher than it used to be, because the warmer atmosphere holds more moisture. So what we're seeing is that these are based on the past. But if things are changing, it gets a little tricky to predict what a 100-year flood even is anymore. So that's just a cautionary tale. It's just, if you're close to these numbers, especially if you live in an area that could flood, understand that those probabilities are probably going to be going up with time. Tornado threat. Hurricanes produce tornadoes. Not every hurricane produces tornadoes. Some hurricanes don't produce any. Some tropical storms produce dozens of tornadoes. So tornadoes need moisture. They need shearing winds. And the hurricanes don't like wind shear on the whole, but in the rain bands of a hurricane, there's shearing winds that can produce tornadoes. So the conditions for tornadoes to develop can become evident during hurricanes, especially on the eastern side. So typically if you have damage and a hurricane moves through, people think it had to be a tornado. Look, everything's twisted. It probably was the eye wall. 130-mile-an-hour eye wall is going to do damage that's going to look just like a tornado. But tornadoes tend to happen more away from the center of the storm. Here was Hurricane Ida. It's tracked through Louisiana, and this is where all the tornadoes occurred, 50 to 75 miles to the east of the landfall. That's very typical. It's very typical that they're going to be either to the northeast or the east of where the storm makes landfall. And again, the Storm Prediction Center is going to produce outlooks every day. We get them right now, showing some severe weather potential this week across the Ohio Valley. During a hurricane, they're going to have an outlook for convective potential, which is going to be exclusively tornadoes. You are not going to get hail. You're not going to get typically damaging straight line winds. You are going to get tornadoes or nothing with these outer rain band thunderstorms that form in hurricanes. They typically are weaker, zeros and ones. Some storms like Tropical Storm Beryl back in the 80s produced F2 and F3 tornadoes, even an F4. So it can happen. All right, as we begin to wrap up, any questions about anything we've covered so far before I tell some personal stories about the hurricanes that I had to work? Yeah. To Hawaii? Yeah. Hawaii gets hurricanes. The outlooks that we're talking about here are really in the Atlantic basin. So in a season like this with El Nino, Hawaii is going to be a little more at risk for hurricanes than a normal year because those equatorial Pacific waters are warmer. Hawaii is in an interesting spot because the waters around Hawaii are not super warm. It's a tropical location, but the waters are not as warm as they are in the Caribbean, the Gulf of Mexico during the summertime. They're 80, 81 degrees, whereas the Gulf can be 88, 89 degrees, which is much more favorable. So Hawaii has had significant hurricane impacts. They're just much more rare than the coastal Carolinas or the Gulf. Okay, this is Hurricane Harvey, August 2017. I think I told the story already about how I was called back to work from Tennessee. So we get back and we're watching this storm, and it's, at first there wasn't a lot of concern. It was forecast to be a hurricane at landfall. So we're saying, prepare for a Cat 2. That was our initial message 48 hours out. Then about 36 hours out, I flew back and my family stayed in Nashville at the time. So it was just myself back home. At 36 hours out, we're on a call with the Hurricane Center. At that point, they raised their forecast to Cat 3 at landfall, and they had landfall right in Corpus Christi, right on top of us. So as soon as we got off the Hurricane Center call, I look around and every single employee was on their phone calling their families saying, get out. So that was a moment I'll never forget when everybody realized we need, except for the weather people, right? We had to stay. So I made time for everybody to have time to go home and board up their homes, take care of their personal effects, get their family packed up and get out. We had 36 hours. And then everybody moved into the weather office. So we have hurricane shutters at all the National Weather Service offices in tropical areas. It's one of those things you never remember, pushing those buttons and cranking those hurricane shutters down, metal shutters that basically lock the entire office down. In the end, the hurricane missed Corpus Christi by about 25 miles. It hit Rockport, devastated Rockport. But we lived in the office for several days. We had secured hotel rooms for the employees that were brought in to assist. Hurricanes have a lot of workload, so we had a couple employees brought in to help. None of those hotels, this was a lesson I learned, none of those hotels had backup power. So when people went back to their hotels to sleep, they had no air conditioning, they had no light. So everybody ended up sleeping in the office where we had a full building generator and air conditioning. We had 10 people sleeping in our conference room. And so the people that were working the midnight shifts would sleep in the conference room in the day, and then everybody would switch and have a little shift briefing and hang out for an hour, and then everybody else would go in and sleep. So it was a different kind of experience to live through. This was the track. We looked at Harvey for a long time, weeks. This, somewhere in here, is about where I got called back. So each of these are 12-hour increments. And then it came in, and once it hit that Gulf water, you can see the brighter colors are stronger and stronger and stronger. right up to landfall it strengthened. Category 4, peak wind was 150 miles an hour at Rockport. And this is the kind of damage we saw, like a tornado, like a strong tornado. Some of the pictures you might have seen, this was all over Aransas County and Rockport. Nobody died. There were no direct fatalities. This was the first major hurricane to hit the United States in 12 years, and not a single direct fatality occurred from the landfall. A lot of people died in the flooding, but nobody died from the landfall of the storm because of watches, warnings, embedded meteorologists and emergency operations centers, extreme wind warnings. People heeded those warnings and got out. Now, there were some lucky situations. A house like this, the landfall was on Saturday morning, Friday night into Saturday morning. On Sunday, weather's nice. It was probably one of the nicest days that summer in South Texas because the wind was blowing, the air was cool, so people were able to get out and start doing some cleanup. Two of my employees wanted to go up and just do a quick survey of how bad it was up in Rockport because we weren't getting a lot of pictures, we weren't getting a lot of reports. And so they drive up there into Rockport over to Copano Bay, and they're taking some pictures. And from a house that looks like this, a guy crawls out from under the rubble. He wasn't injured, but he was living under the rubble of his house. And he was like, are you from the government? Are you here to help? My two employees from the Weather Service were the first people he'd seen at his house. There's no cell phone service. There's nothing. There's no way for him to communicate. So we were able to get him some help, and he was fine. But that's just some of the things that happen in a hurricane like this that are unbelievable. So this was August of 2017, first hurricane. I wanted to get some tropical experience in my younger self, and I was like, wow, that was really amazing, terrible. I never want to see that again. Then I got a promotion, and I moved to Tallahassee, Florida, to take over the office that serves the part of the Florida Panhandle, basically from here over to here. My 40th day as meteorologist in charge at Tallahassee. I don't even have an apartment yet. I'm still living in a hotel waiting to find a place to live. Hurricane Michael happens. And don't you know it? As it's starting to develop, I'm back in Corpus Christi, and I get a call from the office saying, Tom, it was over the President's Day. It was the President's Day. It was the Columbus Day holiday weekend. So I was out of town for the weekend. I had to fly back right away and lead the team through another hurricane. Harvey was primarily a windstorm with some shear, with some surge. Michael was the strongest windstorm I've ever seen, and a devastating and deadly storm surge. So here's Michael's track. Again, very rapid intensity. Remember Harvey, we saw it coming for weeks, literally weeks. Michael, it went from nothing to a major hurricane in just a couple days. So we had to react quickly. This is Mexico Beach. Like I said, I've never seen anything like the surge that happened at Mexico Beach. Mexico Beach was different. The conventional wisdom in the Panhandle, this part of the Panhandle, is hurricanes don't really hit here. They hit further to the west or down in the peninsula. We don't get them here. So the building codes were actually weaker in the Panhandle than they were in other parts of Florida. And Mexico Beach was built out mostly in the 50s and 60s as early retirement communities where the homes were just on slabs. They were not built up homes. So there was some homes you'll see that are on slabs that are less damaged, but the homes that were not built up were destroyed. And this is what it looked like. So only 5 deaths. I say that only 5 because every one of these homes was not survivable, but most of the people left. So during the evening hours the night before landfall, we had one of our meteorologists at the Bay County EOC, the Emergency Operations Center, Panama City. At 10 o'clock at night, we're hearing from the Hurricane Center where there's still people in Mexico Beach. We're seeing reports that a lot of people are staying. And our meteorologist had worked a 14-hour shift. He was taking a nap at the EOC there in Bay County. We called him and said, is there anything we can do to get people out of Mexico Beach? Because the surge forecast was just devastating. We had 12 hours. Mexico Beach is not Houston. There's 3 or 4 roads out. There's a few thousand people. People can get out and go at the last minute. So they got their emergency crews together. He woke up the emergency manager, who was also sleeping. They got everybody riled up and said, let's get down there and go door to door and utilize our warning systems. Let's call everybody. And after about a 3 or 4 hour effort of working over that town, they got about 500 people to leave. 10% of the people that stayed died. So if 500 people left, the death toll would have been a lot higher than it had not. Some people, we found out the stories of every person that couldn't leave. Some just couldn't leave. They didn't have a vehicle. Some didn't think it was going to be that bad. All of them were over 70 years old. And I think it was a retirement community, and I think it was just difficult for some of the people just to have the confidence to say, I'm going to go ahead and leave my home to go to points unknown. So a tragedy, but you can see that is unbelievable devastation and unbelievable beauty. So this is a picture taken during Hurricane Michael near Tyndall Air Force Base. I think it's the clearest, best picture of a hurricane eye from the ground that I've ever seen. That is the hurricane eye. That's it. From the ground at noon, sun shining, all the devastated, blown down trees. The winds are about to pick back up from the other direction here in 5 or 10 minutes as this hurricane passes. But look at the curvature of the clouds. That is Mother Nature's power at its extreme right there. So we saw the worst and the best of Mother Nature with Hurricane Michael. So an unbelievable picture of inside of a hurricane eye. The last hurricane I'm going to talk about is Hurricane Ike. How many of you guys were in Ohio when Hurricane Ike's remnants came through in 2008? Hurricane Ike caught people off guard. So Hurricane Ike had a massive storm surge on the Bolivar Peninsula and areas of far northeast Texas and western Louisiana. And then Hurricane Ike just kind of meandered through the lower Mississippi Valley and the Midwest for a few days. And then all of a sudden it accelerated and it blew right up through the northern parts of Indiana into Michigan. And as it did, it tapped into the jet stream. And it was able to take jet stream level winds and mix them down to the surface of the earth, with Ohio in the epicenter of the impacts of Hurricane Ike. So in Columbus, in Dayton, Cincinnati, and all across the state, trees were blown down, buildings were crushed, cars were crushed. There was 7 people killed and dozens of injuries. Over $1 billion in damages from a remnant hurricane over the Buckeye State. This was the costliest weather event to hit Ohio since the Xenia tornado in 1974. 2.5 million people without power. Some of the people I later worked with when I came back to the Weather Service in Wilmington didn't have power for 2 weeks. So those are hurricane-like numbers. When you don't have power for 2 weeks, you know it's a bad storm. So Hurricane Ike is the Ohio storm that if you read the intro to my talk that we're going to talk about, 75 to 90-mile-an-hour winds. It was a hurricane in terms of wind speeds and gusts as it came through Ohio. So don't think it can't happen here. It can. All right, so as I wrap things up, we'll have a few minutes for questions here. My email was at the beginning. If you want to email me, hit me up, ask me a question. That's my personal email. I'd love to answer. Nash Severe Weather, that's my job now. So I do digital meteorology for Nash Severe Weather. We're available on X, Facebook, Instagram, Blue Sky, whatever your favorite. If you want to get a feel for what we do and how we do it, check us out on those platforms. And I joined the podcast game this year with some retired friends of mine. We talk about big weather events, kind of give the inside scoop. If you've seen Captain Steve or any of these other podcasters that kind of take a deeper dive, we want to do that for weather. So we're available on Apple, Podbean, if you're into podcasts, you know where to find them. Look for the Debris Ballers. That's our name on our podcast. So thank you all so much. Yes, sir.
You said that perhaps during the Ice Age that there were hurricanes?
Yeah.
Evidence for that? What would be the evidence?
Evidence of surge in areas that were sediment surge and other things, like lake bottoms in Florida and those kind of places that indicate there was some kind of surge that came through there. And just physical, we've modeled it. So it can be modeled to indicate that a cooler earth still supports hurricanes. So it's not 100%, but there is evidence that there were. Yes, sir.
Could you speak to for a moment about the effect on the National Weather Service of the budget cuts?
Yeah, I mean, the budget cuts came at the worst possible time for the Weather Service. It was during the time I retired last year, because the Weather Service has had struggles hiring going all the way back to sequestration, 12, 13 years ago. So the Weather Service was running behind in terms of their staffing. And then along comes a change where a lot of my friends were offered early outs. The Weather Service lost 15 to 20% of its workforce over the course of a year. Its most experienced workforce. So not so much from cuts, but from kind of a change in the staffing model and a desire just to make a smaller government footprint. But it really hurt. It hurt a lot of people because the offices didn't have enough people to staff. They didn't have the technicians to fix the equipment, so we're seeing radar outages that are up. We lost experience, so we're seeing a decrease in warning and forecast skill because you have much less experienced staff carrying the load. And it'll take time to build that experience back up. So the impacts were significant. I will say does seem to be getting a little better now. Several hundred meteorologists have been hired this year, and things are turning around. But it was a bad time in the last year, absolutely. A lot of my friends are still suffering from having to go through all that. Yes, ma'am. So hurricanes happen in the Atlantic Basin, typhoons happen in the Pacific Basin, especially the Western Pacific. So there's no difference of the same structure. Now, a typhoon in the Southern Hemisphere does go the opposite direction, but a tornado in Australia does not flush the opposite direction of a tornado in the Northern Hemisphere. It's one of those things everybody assumes true. It's not. The Coriolis effect, sometimes called a force, but it's an effect, needs hundreds of miles to cause that curvature to occur. So just water going down a basin doesn't have any time for the Coriolis effect to have an effect. So it's simply a matter of the design and how the water goes in the bowl. So if you go to the equator, water's going to swirl down the basin. It's one of those interesting things that you probably could win a bar bet on that one if you really wanted to.
All right. Thank you very much, Tom.
You guys were a great group. Thank you. Have a great rest of your day. Stay cool.